Now it seems to be working. So let's start. 10 minutes late, but let's give this talk about accessibility. First thing, well, as I said to Shirley, James came a bit later. If there's anything, you can either stop me by the chat or by talking on the, if you have a microphone, okay? So accessibility, start by a definition. What it is. So I'd say it is everything that makes possible the interaction between human beings and computers. And of course, accessibility has also the added sense of some special need when it comes to accessing this computer, right? These special needs can be of many different types. So we call them impairments. Sometimes we call them people differently able. So typically we think of blindness, and it's not only blindness. So the first one, what regards the numbers, is probably learning or communicating disabilities like dyslexia, autism, hyperactivity, many different things that can be a disturbance. And when we deal with accessibility, we also have to deal with these sort of problems or differences in our audiences, right? Or in our users or students and so on. Second one, visual impairments, complete or partial, color blindness, anything that makes us see the screen differently, right? Third one is hearing impairment, which can be complete or partial. Of course, when it comes to Moodle and mathematics particularly, it is not very relevant to what we do. It would be more relevant for videos or for other subjects, maybe for languages and so on. But we won't be talking a lot about listening or hearing issues, right? And the fourth one is motor dexterity impairment. So we can be paralysis. So we have to think that some people are managing their computer with a specific keyboard, or maybe by just moving a foot or the eyes or with different parts of the body. So they cannot handle a mouse or a complete keyboard. So they have different elements, different hardware to access the contents, both to read them or to create them. And we'll also deal with this one. Good. So now we have a bit of a reference of what we're talking about. And I'll start becoming more specific. So when it comes to Moodle, when do we need accessibility? So there is different levels that I classified. So content creator can have accessibility issues. Teacher, the student, of course, is the most common because it's the highest number of people that we have in the platform. And then I grade administrator, because when it comes to mathematics, so the administrator will not be doing as much actively. I mean, so they can install a plugin for mathematics, but not really solving exercises or creating exercises for mathematics. So I would say these three are the three roles that are mostly affected by accessibility issues in mathematics, sciences. And when does it play a role? Well, it plays a role in content interpretation. So that can be the student reading an assignment or the teacher grading an assignment, right? So anywhere where some people have created a bit of information in a forum or in a mail or whatever, and then it has to be interpreted or accessed. And the second point is content creation. So when the teacher or the content creator prepares a lesson or prepares a quiz, prepares whatever, so he can also have accessibility issues, which not only refer, so it's a bit different the approach. So it's not only displaying a math formula, but in this case it would be also what happens if I want to create a formula or edit a formula. Right? So what's the approach? What's the thing that happens for mostly for visually impaired, but also for these other impairments when it comes to dyslexia or other cognitive, so learning impairments. So what we do, we have a formula, so it's a bit tiny. I'm going to zoom in. So we have a formula, and well, at this level, you can also see it here, I think. And we have, wasn't prepared for this with Zoom. So we have a verbal description. So instead of offering the student the image, we offer him a verbal description, 2 to the power of x plus 1 and exponent in this case. This can help people with dyslexia and also people who have a screen reader. So blind people, they typically have a screen reader which will read out loud everything that happens on the screen. So although it is crucial to accessibility, I don't want to do the test because it's a very annoying experience to all of us who are not used to hearing JAWS or another reader. That's the most common one, JAWS, or another screen reader doing the work. So we need to offer the screen reader this verbal thing, right? And I'm going to enter into a bit of a more abstract way of doing this accessibility thing. None of us, if this can be translated to other languages, we have now English and Spanish. Of course, I would say accessibility accepts any language. So, and Catalan we also have, but I guess it's less important for the American continent. The English and Spanish come already. Good. And I was about to talk about different types of verbalization. These types can be grammatical or prosodic. So I'll talk about the two types in a sec. I want to also be synced with the chat. So this is a part. So this is internal to Wiris, what we do. But I'll talk about the Wiris editor when we come to the specific part of how we deal with things. So I'll now present the thing in a more abstract way, and then possible resolutions of the different problems, right? So as I was saying, there are two ways of translating the formula, the image, into text. The first one, grammatical, you see the two examples here. So we make specific everything in the formula. So 2 to the power of x plus 1 and the exponent. So this way, we sort of group this x plus 1. If we want to go for the prosodic approach, we say 2 to the power of x plus 1. And this way we make also clear in a different way that x plus 1 belong to a group. The other example here would have a grammatical form, 2 to the power of x and exponent plus 1. Whereas the prosodic approach would be 2 to the power of x plus 1. We have this pause here to make us note that there is a group here built with 2 to the power of x. What are the good things and bad things of these two approaches? So grammatical is a bit more cumbersome, a bit more complicated. That's the bad part, but it's unambiguous. So you can always be very precise about what you're saying. Whereas the prosodic, it's simpler. It's also more natural because it relates to how we speak. But it can also be a bit more complex to understand by someone who has a learning disability like dyslexia or hyperactivity or one of these issues. because it has to do with timing and things that can be more personal, and it can also be ambiguous, right? So I have this little example here. I think I have it on the next slide, larger. So when it comes to more complex things, we can still do it with both approaches in this example. So I could say numerator 2/3, denominator 4, numerator 2, denominator 3/4, or 3 divided 4, with a grammatical approach. Or we could say 2/3 divided by 4, or 2 divided by 3/4. So it works, but it can be a lot more subtle, and it can be ambiguous when it becomes more complex, right? Good. Before going to the more specific things, I wanted to read this statement from Mika Cepeda. I'll read myself and then I talk about Mika. So currently, there is a complete mismatch between mainstream software for mathematics and existing screen readers when it comes to multimodal presentations of formula. In most cases, formula are printed on the screen using graphical glyphs, so images. Hence, learning environments are basically unusable for mathematics by people with disabilities such as dyslexia, dysgraphia, and any visual impairment. So this statement has it was done 2 or 3 years ago, but I'll show at the end that not much has happened that makes this not valid anymore. So it's basically the state of the art. And Mika Cepeda, he's been involved in some projects that I'll talk about, and he's one of the main or one of the biggest figures in actively working on accessibility in mathematics. And we'll talk about him later also when we go to the concrete projects. Good. Let's go now for what we do with a math formula and a screen reader. There's basically 2 approaches. So I've called them the plugin approach and the image approach. And it basically has to do with what we do with the math formula when we're not talking about accessibility. So in general, how we present it, how we store it, right? So basically, if you're storing your math formula as MathML, your screen reader will not be able to use it. So what you do is you install a plugin that transforms the MathML into a textual description like the one that we just had, like 2 to the power of x plus 1 and exponent, or whatever similar, right? And that is the first approach. So install a plugin in your computer. You'll see that it has good things and bad things. Let it be more specifically what happens. So there is a formula, there is MathML that we store in the HTML page, and then the plugin transforms this into 2 to the power of x plus 1 equal 9, for example. Right? And that's one approach. Let's see the pros and cons. Bad points. Dependence on external elements and technologies and incompatibilities on different devices and OSs, which means if I have different devices that are able to give me accessible content, I need to be able to install this plugin on my computer, my tablet, my telephone, on everything, right? Which will not always be the case because there are different technologies behind each thing. On the other side, there's some very good things. It's convivial with CSS and text formatting. And the formula adapts to user parameterization of the screen. These may seem minor to us who are used to just accepting the website as they come. But you have to think that people with a strong reduction of their sight, so people partially blind, they have very customized CSSs, and they access the content with strong contrast between black and white, magnifiers, so a few things that make the content very different from what we're used to. So being able to adapt to this user configuration can be very important, right? That's for the strong points of the plugin approach. Second approach, the image one. already advanced. It's the one that we chose, the one that we do at Wiris. So we save images for the formulas. So this way we make sure that you can see that in every tablet, in every telephone, anywhere, right? And what we do is on this image, we store an alternative text. Like it could be, you could have it on any type of image. So if you have a landscape in whatever, so a New York landscape, so you can have alternative text, skyline of the city of New York, right? For formula, if you don't have anything, the screen reader will also be lost, like in the MathML. So he will only read the name of the file that stores the formula, which will be a horrible number.png basically. So you really need to create alternative text and to do it automatically, because otherwise the author will never be doing the effort to introduce this manually every time. So as I said, you have an image, you create a verbal description, the image that you store in the alternative text, and this way the screen reader will treat it as any other image, right? So show also how it works. So you have the formula, the image. There is here. There's no special code or something, right? It's just grade or the limits of the image that you can see that it's stored as an image. And then the alternative text that we create, and this is what we attach to this image and we give to the screen reader to read. I'll show you with the context of a Wiris generated image. So basically, you have the formula. There is, you can see it with a right click. So there is an alternative text, and you store the verbal description. With this approach, again, good things and bad things. Bad things first. It's less convivial with CSS and different text styles because it's an image, so it's not affected by much of what happens around, which we'll see is also a bit of a strength. But in this sense, it will not adapt as good to the properties of the screen of the person viewing it, right? And as I said, there's normally strong magnifying in partially blind people, so by enlargement of the formula, it loses quality due to extrapolation like any other image, right? So these are the bad things. And the good things is that it's independent of plugins in screen readers, and this is a robust system, so any device, of course, can show an image, otherwise it's not a smartphone or not a tablet. So in this sense, if you have accessibility in your device, then you automatically have math accessibility in your device. And the second point is, transversally deployable in different devices and OSs. So basically, it's very portable. So it's very easy to handle. We've taken this way. We think it's the less damage cost on the user experience. So of course, there is a loss of quality, we can say, but you can still work with it. Whereas on the plugin approach, you can be simply blocked out from accessibility, from accessible content. So that's the main reason of adopting this approach. Good. Been talking about what happens to accessibility, what refers to content visualization, so the formulas that are created. But I want to talk for 2 minutes now about accessibility for content creators. So what happens when I am the teacher or I am creating the content? How am I supported? So the first thing, of course, is that whenever you start typing, make this larger, whenever you start typing, you also get your formula read out loud, so you can hear what happens on your screen, right? But that is one part of the accessibility, as I said. If you have another of the impairments, which is I am creating content, but I have a dexterity problem. So I am managing the editor with only one foot, or if I cannot handle the mouse for any other reason. So we have also done some work on this. So and you can also, from whichever method you use, do some work on this. Yeah. So I have a few slides simulating the tabs, because this is not live. I'll show you the Waris editor live in a sec. But basically, we have been very careful about making the movement on the different tabs, on the different items on each tab. So you see the first one is now selected. You tab, go to the second one, tab, go to the third one, paste, you go to the formula in case you want to type. So there has been a very precise and very careful work on this, right? Which is maybe a good feature of any software, that when it comes to usable or not usable, then it is crucial. So you need to make sure it's perfect in this sense. Because some people will be guided, so it will be the reference for them. Good. That's the main things that have been done. The audio for the blind people or partially blind, and the tabbing and spacing and key things for the dexterity impaired people. And then there are some other things that are going to come. So they're in our roadmap, which have to do with more with the magnifying, high contrast, these sort of things, right? So there's a few things get planned. So we are doing first steps, I would say, and the industry is in general doing first steps on this. Good. And as a last part of the presentation, I want to leave, so I will only talk for at most 10 more minutes, and I want to leave some time for the questions. But I wanted to present a bit the projects that have been tried in the past for doing accessible contents. So there's many minor projects. I'll talk about 4 of them. So this IHS project is a large one, just completed. It's been a 6-year project funded by the European Commission and many other people. You can see companies, universities, and many more that I left out. And this one is a generic project dealing with accessibility, very interesting when it comes to standard definition and to thinking things from a very abstract way. But for us, it doesn't address the specific thing of mathematics, and it doesn't provide support for the content creators. So these are the 2 main drawbacks. So it's a general project, very interesting on its own, but it doesn't address science and mathematics. I'll go now to the more specific ones. Lambda project, so launched in 2009, also focused on accessibility from the blindness point of view, and they have worked on, as you can see on the second point, developing an editor for writing mathematical expressions through braille peripherals and speech synthesis. So this is some also very new things, also at their starting point. So there's not very much that has been implemented. So this one was funded by ONCE, which is the Blind People Association in Spain, which is worldwide one of the most important. So it's very powerful and has many resources because they manage the lotteries, or some of the lotteries in Spain, so they have money. And they launched this project, but it's not very much in use now, so it was explained here. So it has fallen short of what was trying to be achieved. And the third one, where we participated also, it was in order to establish like a language independent mathematic structures. So it has to do with accessibility in a sense, but it was also like in European languages and different languages. So the approach was really wide. It had some good results, but it was too theoretical. And the last one that I present is Malmo, which is the effort to transform this theory into, so this web art theory into contents, into something that can be used. Good. To finish and answering some of the questions that Nadav had, I'll show you a bit more in detail what we specifically do in Wiris with the editor. So you can see it working. We've seen a few screenshots, but I would like to show it also on real time. I'm happy because I forgot that I had lost I had to close my browser to turn it off and turn it on because of the issue. Technology issue. Good. So now I'm sharing my screen. Are you seeing it? If anyone can say yes in the chat, that would be great. Excellent. Thank you, Paula. So basically, the editor, as I said, you can tap through the different tabs where everything is here prepared, so you can see it's pretty complete. So that's the first one. So the main things are here. And then I type anything, and we have this accessibility text here. So this is just a demo. So in the normal world, so an image would be created, and this image would have like attached this accessible text as alternative text, right? But in this demo, you can read it here. So square root of x plus 1 and root to make this different from having here a plus 2. Or, sorry, I don't want to make it complicated, of having it here. Square root of x plus 1, right? So this generates the image with the alternative text. Another question was the languages. So today we have English and Spanish with accessibility. We plan to have many more. So actually the effort that has been done makes it fairly easy to translate to other languages. So the big thing is transforming the mathematical grammar, let's say, into spoken language. Once this is set up, then be it Spanish or French or any other, so it's relatively easier. Right? And just to give you a 30-second publicity slot of the editor, so there is different toolbars. So we have the simple one, the complete one. The third one that will come in as a default one will be chemistry, because we're developing some chemistry-specific things. And you can set up your own toolbar if you wish. And also something that my colleague Ramon, who is now also listening to the session, will present on Saturday or Sunday, or both actually. So we'll do one each. Is the Arabic one. So you see, this is something pretty special, not only because it's right to left, also because of these are numbers. So because of the Arabic numbers and the mirroring of the formulas. So there is different levels. So in some Arabic countries, in some Arabic countries, they write right to left. The formula then is not mirrored, and then they continue writing right to left. Or some others, they have different configurations. Let's say. So we have also tackled this thing with the Arabic language, right? And well, that was about it for the editor. So if you want to play with it, you can go to wiris.com/Moodle, and you have access to this demo where you can play with the editor. We also have a computer algebra system, which is a calculator, and support for the quiz system that comes in Moodle, so directly integrated. And you can hear a comment and play with it. And also in our website, you can download everything. Wiris.com/Moodle. you can try it on your own Moodle and see how it works with your users, with your teachers, right? So you can come here and download our stuff, install it, and see how it does for you. And now I'll stop sharing my screen. Good. And I'll leave some time for the questions. So first of all, thank you all for being here, for your attention. And if you have questions regarding our work, the Wiris thing, the Wiris plugin, the Wiris formula editor, or generic about accessibility, well, I'll do my best to answer, because I'm not an expert on accessibility, but I've read a bit. So there is, so you mean if Wiris works in Moodle 2.5, right? I would say yes. So we tend to be very proactive on the upgrades, and you can see it on our installation in the download. So there's one download for the 1.9, one for the 2.3, 2.2 and 2.3, I think, or 2.3 and 2.4. Sorry, I'm being confusing now. So one for the different versions of Moodle. So, but we are very proactive in creating the different plugins. Thank you, Shirley, for the good feedback. And Malita says she didn't see it on the site. Do you mean the Moodle plugin site or ours, or the Wiris site? Okay, Ramon, who is my colleague, writes a big yes to Moodle 2.5.
Can I say hello? Can you hear me?
Yes.
I'm just asking the team here about Moodle 2.5. Looks like we are like touching the last details. It looks like it doesn't work in it right now, but we're working to make it work in the next days. Okay.
Okay. It will be within days there. Thank you, Paula.
Well, of course, we tell me we have several components in Moodle, like the editor and the quizzes part and other things. So the editor, which is like more stable in that sense, is working okay with Moodle 2.9. So the accessibility is working okay with 2.5.
Good. And Malita, can you be more precise about your question? Because you say, I didn't see it on the site. I would like to find it for you if you need more details. Oh, she's gone. That's why she's not answering. That's fine. So I guess she must have seen it now. Good. So there's not any more questions. So thank you all. You have, well, our site is wiris.com. So you can, you see that we are very accessible also from the contact point of view. So all the information, the downloads, the documentation is very easy to find. And you can also say we're mathematicians and we are very structured on the presentation of everything. So thank you, everyone. And well, I'll see you on our next presentation if you wish to see the Arabic part.
Hi Carlos, Shane here again. Just wanted to say thank you very much for doing the presentation. Turned out it was really good doing that second one, so thank you.
Thank you, Shane, and thank you for the support. Your hint about what to do with when I was blocked was crucial to bringing me quickly back to life, so thank you.